Okay, this video is about another technique for solving a system of equations, and this technique is known as elimination. All right, so our goals are, can we solve by elimination, whether we got to do one adjustment or two adjustments, and what are possibly some special solutions that can come out as of this. Remember our three methods for solving a system: graphing, substitution, and this is the final one that we are going to study. There is more than this, but that's the final one that we're going to study, called elimination. So how does elimination work? All right. Elimination, I like to very much oversimplify the process. All right. Elimination is also known as the addition, subtraction, or multiplication addition, or multiplication subtraction technique. I like to clean it up and make it really, really cut and clear. All right. The first thing you got to be able to do is write equations in standard form. We want to take standard form and figure out a variable to eliminate. And what we're looking for are variables that are opposites. All right. If they are not opposites, we're going to need to adjust any equation so that one of the variable coefficients are opposites. So that means we might have to multiply an equation by as simple as -1, or multiply one or even both equations by a particular value to get the coefficients to be opposites. We're then going to do what I like to call merge. We're going to take the two equations, squeeze them together, which will force one of the variables to eliminate. All right? Then we solve for the remaining variable, substitute back into the original, one of the originals, solve for the other variable, and then write the answer as an ordered pair in the form xy. Excuse me. Okay? All right, so let's jump in and see how we do this. All right? When I look at these two equations, -4x plus 3y equals -3, and 4x minus 5y equals 5, I notice right now that both this variable and this variable have terms that are opposites. I'm now ready to merge. So that equals line right there is really kind of like my merging line. I know that -4x and positive 4x combine to give me 0x. So my x's are right now eliminated. I follow the same pattern for each of the other terms. So in other words, positive 3y and -5y, they would combine together to give me -2y. -3 and positive 5 combine together to give me 2. Now I have a single equation with one missing variable. Divide both sides by -2, and I get y as -1. Look at that. We already found one of the variable values. All right? If I take that value and substitute it into either the first or the second equation for y, I'm now going to be able to solve for x. So I'm going to choose to do the top equation. I have -4x plus 3 times -1 is equal to -3. I do that little multiplication. That gives me -4x minus 3 equals -3. Add 3 to both sides, so we're just solving right now. I get -4x equals 0. Divide by 0, I get x, or sorry, divide by -4, I get x is equal to 0. I know that this system has a point of intersection at the point 0, -1. Now, why would I want to use elimination? If you notice in that system, neither one of the equations could be solved very quickly for a single variable. All right? That's why elimination is a valuable tool to learn. So let's look at this second one. All right. It looks like the A's are going to eliminate, but right now they're not opposites. I always have to make them opposites before I do my merge. So I'm going to rewrite this system. That's what that arrow means. The top equation is going to be 8a plus 3c equals 11. The bottom equation, I want to make this 8a become -8a, which means I have to multiply each and every piece in that equation by -1. When I do that, when I distribute it through, I get -8a minus 7c equals -7. I'm now set up to combine and merge, and if you notice, the A's eliminate here. I know that 3 minus 7 is negative 4c. I know 11 minus 7 is positive 4. Divide both sides by negative 4, I get c is equal to 1. I now have to go back in and find a. I can substitute it into either of the original equations. I'm going to choose the first one. 8a plus 3 times 1, I replace that c, is equal to 11. Or 8a plus 3 equals 11. Subtract the 3, I get 8a is equal to 8. And divide by 8, I get a is equal to 1. Now, we have a unique scenario now as well. We don't have x's and y's. When this case happens, you want to follow alphabetical order from writing your point of intersection. In other words, in this case, I'm going to write A, then C. All right, so the point of intersection is 1, 1 for this system of equations. Let's take a look at the third example here. Now, when I analyze this system, I notice that the x's, I could multiply one of the equations by a value to make the x's disappear. All right? I know that if I make this second equation's x become a negative 6, then I'm going to have a system that I can merge and something will eliminate. So the top equation, I'm going to rewrite it as 6x minus 2y equals 10. In the bottom equation, distribute that negative 2 through, and I get negative 6x plus 14y equals positive 38. They're now set to merge because the x's are opposites. So if I solve this now, I have negative 2 plus 14, well that's 12y, and 10 plus 38 is 48. Divide both sides by 12, I get y as 4. To find x, I need to substitute. I'm going to choose again to plug it into the top equation there for y. So I have 6x minus 2 times 4 equals 10, or 6x minus 8 equals 10. Add 8, 6x is equal to 18. Divide by 6, x is equal to 3. I'm going to write this coordinate point as the point 3, 4. All right, a few more examples of this. Trying to show you guys all the different possible scenarios that could happen. Now, look at this one. I've got a 5x and a 2x. I've got a negative 3y and a positive 5y. I have no idea which variable I want to try to eliminate because nothing could be done very simply. Here's one thing I do notice though. I notice that the y's have opposite signs. So I'm going to have to change both equations so that the y's will eliminate. All right, I'm going to multiply the top one by 5 and the bottom one by 3. And when you see the rewritten system, you'll see why. I have 25x minus 15y equals 30. In other words, I was trying to find that common multiple of both 3 and 5 for the y's. In the second equation, I have 6x plus 15y equals negative 30. Now notice what happens. I now have opposite y's, so they're going to eliminate. I'm left with 31x is equal to 30 minus 30 is 0. Divide both sides by 31, I get x is equal to 0. Now I got to plug it in to go find y. I'm going to substitute it this time into the second equation. Why? Just for fun. So I have 2 times 0. 2 times 0 plus 5y equals negative 10. 2 times 0 is 0, so really this just says 5y equals negative 10. And if I divide by 5, I get y as negative 2. The solution to the system, or the point of intersection, is the point 0, negative 2. All right, let's take a look at number 5 here. All right, what do we want to eliminate? How about we eliminate y's? All right, that means I got to make these y's opposites of each other. All right, I'm going to multiply the top equation by 3 and the bottom equation by negative 2. And the reason why I did that was I know I wanted the y's to have a coefficient of 6 and negative 6. So let's see what our new system adjusted looks like. 18x plus 6y equals 6. I distributed that 3 all the way across. Negative 8x minus 6y equals negative 16. And when I do that, I notice I'm ready for a merge because the y's are opposites. 18 minus 8 is 10x. 6 minus 16 is negative 10. Divide by 10, I get x is negative 1. I'm going to substitute it back into, let's do the top equation. 6 times negative 1 plus 2y equals 2. Or negative 6 plus 2y equals 2. Add 6, I get 2y is equal to 8. Divide by 2, y is equal to 4. The point of intersection is negative 1, 4. All right? All right, so how about this one? Well, let's eliminate x's here. If I'm going to eliminate x's, I know that I'm going to have to adjust the top equation by multiplying it by negative 2 so that my coefficients become negative 4 and the other one is already positive 4. So they'll eliminate. So let's see here. I have negative 4x minus 6y equals negative 8. And the other equation I didn't need to adjust, 4x plus 6y equals 9. So the x's, when I go to merge, the x's are going to eliminate. But what else happens? The y's eliminate. Well, now everything on the left side has been eliminated. I still need to hold that place, and I'm just going to hold that place by putting a 0. I have 0 equals negative 8 plus 9. That would be 1. So here's that special case. Is this true or false? This is false. And if it's false, that means there is no solution. In other words, these two lines will never cross over one another. Okay? Let's look at one more here. In this case, what do you want to eliminate? Let's eliminate the x's again. So I'm going to have to multiply the top equation by negative 3. When I do that, I get negative 3x plus 3y equals negative 3. You got to be real careful when you're multiplying through. The second equation is 3x minus 3y equals 3. Now we did this so that I would be able to merge and my x's eliminate. But I also notice my y's eliminate as well. Negative 3 plus 3 gives me 0 equals 0. Well, that's obviously a true statement. If it's true, that means infinite solutions. All right. Hopefully these videos help. Good luck. Let me know if you have any questions.